If you're the kind of person who thinks that math lessons sometimes go a bit too slowly, and you find you're playing with your phone or watching TV at the same time as doing your homework, well, you're not going to be doing that today because I'm already asking you to do more than one thing at a time. My name is Miss Danielson, and today we're solving simultaneous equations. That means we're solving two equations at the same time. This is an introductory lesson to simultaneous equations where we'll be using the elimination method. For the purpose of this lesson, I'm going to go ahead and assume that you already know how to solve an equation. When you have an equation with only one unknown variable, and remember a variable is a letter or symbol that represents some value that we don't know, we can find the value of that variable by just rearranging that equation. So for example, 4x minus 5 equals 15. In this equation, x is our variable. Right now, x is being multiplied by 4, and 5 is being subtracted. So working backwards, the opposite of subtracting the 5 is adding it. So now I have 15 plus 5 on the right-hand side. Simplifying that, 4x must be equal to the answer of 15 plus 5, always working downwards, is 20. But I want to know x's value. I want to get the variable by itself. That's being multiplied, so the opposite of multiply is divide. So I've now got x on its own, and on the right-hand side, I've got 20 divided by 4. So working vertically, x must be equal to 5. We can always check our answers by substituting them back into the original equation. 4 times 5 is 20 minus 5, that is 15. So we know we have the correct value for x. Now moving forward, I'm going to assume that you understood how we just solved that single variable equation. If not, check out the description box below for our previous lessons. But let's move on to simultaneous equations. First of all, simultaneous means at the same time. If you've got an equation that's got two unknown variables in it, that's two different letters, you're going to need two hints, so two different equations to help you find the values of those two variables. For example, if you're given an equation like 2x plus 3y equals 8, there are two values there that you don't know. You don't know what x is and you don't know what y is, which means there could be many different combinations of values that would make this equation equal 8. For example, if x is 1 and y is 2, that would be 2 times 1 is 2, plus 3 times 2 is 6, 2 plus 6, that makes 8. That's one possible set of answers. Can you think of another one? What about if x is negative 2? If x is negative 2, 2 times negative 2 is negative 4. And if y is 4, 3 times 4 is 12. Negative 4 plus 12 is also 8. So there's more than one possible pair of solutions to this equation. Because we only have one equation but two unknown variables, we can't possibly know which pair of solutions is the correct one. So here's another hint. 2x plus y is equal to 0. Now notice I'm using the same letters, the same variables in these two equations. That means that x and y in the first equation must have the same values as the x and the y in the second equation. Now that we have two hints, we can find our two unknown values. If we had an equation with three different variables, like x, y, and z, for example, you would need three different hints or three different equations to help you solve them. But we're not going to worry about that for today. Let's carry on with this example. So I've got my two equations. The very first thing that we need to do, and you're going to want to write these steps down, is label your equations 1 and 2. It's a very simple step, but please don't leave it out because we're going to do a lot of working here and it's going to be so much easier to follow if you have it nicely organized. So equation 1 and equation 2. Step 2. Check that both equations either have the same number of x's or the same number of y's. Looking at my equation 1, I've got 2 x's and 3 y's. And looking at my equation 2, I've got 2 x's and a single y. That's 1 y. I do have the same number of x's. I have 2 x's in both cases. Just a bit of vocabulary for you. The number that's in front of a variable is called its coefficient. So in this example, my x terms have the same coefficients. They both have a coefficient of 2. Step 3, we're going to eliminate one of the variables, either the x variable or the y variable, by subtracting the two equations from one another. So I'm going to go ahead and set this up like a column subtraction. I'm just going to put a line underneath these two equations, and you see my minus sign out front. I'm going to label my answers. So if I'm doing equation 1 minus equation 2, I'll write that out front here. And I'll go ahead and subtract term by term 2x. Subtracting 2x would be 0 x's, so nothing. That has eliminated my x variables. Going on to the next terms, 3y, take away a single y, that's 1y, would be 2y's. And don't forget to also subtract the values on the right-hand side of the equation. So 8 minus 0, well, in this case, that's still just 8. By doing equation 1 minus equation 2, we end up with a single equation now, which only has one variable, because we eliminated the other. 2x, take away 2x, no more x's. So step 4, we're going to solve the remaining equation to find the value of this one variable we've got left. So to get the value of y, we need the y on its own. Y is being multiplied by 2, and the opposite of multiplying by 2 is dividing by 2. So y is equal to 8 divided by 2. And of course, working vertically, 8 divided by 2 is 4. So we've got the answer for y. However, we are not finished yet. Let's keep going. Step 5, once we know the value of one of the variables, let's put a box around that so we don't lose it, but we're only halfway there. We know that y is equal to 4, but we still don't know what x is. So step 6, substitute the value we found into either of the equations to find the other unknown value. So it's your choice. Whichever equation you think is going to be easier for you, you can use. I'm just going to go ahead and use equation 1. If you used equation 2, you should still get the same answer. In equation 1, we're told that 2x plus 3y should be equal to 8. But if y is 4, let's replace that y with a 4. So we're saying 2x plus 3 times 4 needs to be equal to 8. Working this through, 3 in front of that 4 in brackets is multiplying, so that's 12. And to find out what x is, we need to undo these operations. X is being multiplied by 2, and then the 12 is added. Let's work backwards, get rid of that 12 first. Opposite of adding 12, we'll minus it and simplify that. And then to get the x completely on its own, we need to get rid of that 2, which is multiplying by the x. So the opposite of multiply by 2, we'll divide by 2. And that gives us x by itself must be negative 4 divided by 2 is negative 2. We've got an answer for y. It's in that box above. We now have an answer for x. X is equal to negative 2. So we've got our answers. X equals negative 2 and y equals 4. You may think we're done now, and we kind of are, but you might have noticed that our working was quite long, so it is possible that we've made some mistakes. Hopefully you've labeled all of your working by labeling your equations, and you'll see that we just finished solving this simultaneous equation by using equation number 1. So next step, let's check our answer. But let's use equation 2. We need to make sure that the x and y values work for both equations. We know that it works for equation 1. How about if I substitute negative 2 in for x and 4 in for y in equation 2? Using brackets, I've replaced the x with negative 2 and I replaced the y with 4. Let's work this through. A 2 in front of negative 2 in brackets means multiply, not subtract. 2 times negative 2 is negative 4, and negative 4 plus 4, that is 0. Now be careful, our answer is not 0, but we know that we have our answers correct because those x and y values made the equation equal to 0 as it should have been. When you do your check, you should see that the left side of the equation is equal to the right-hand side of the equation. Before we move on to the practice exercise, let's see those steps again. If you haven't written them down yet, make sure you get them down now and make sure you follow them. Step 1, Remember to label your equations 1 and 2. Step 2, check that both equations either have the same number of x's or the same number of y's. Now, if they don't have the same number of x's or y's, we won't be able to solve those questions just yet. But we will be looking at questions like those in our next lessons, so watch out for those. Step 3, we're going to eliminate one of the variables, either the x variable or the y variable, by subtracting the two equations from each other. Step 4, we're going to solve the equation that we're left with that's only got one unknown variable in it. Step 5, it's not really a step, but it is encouraging. Once you find the value of that one variable, put a box around it. We are halfway there, but we need to keep going. Step 6, substitute the value you found into either of the two equations. Remember to label them either equation 1 or equation 2, and work that equation through to find the value of the other unknown variable. Step 7, once you've got your two answers and you've put a box around them, make sure you check your answer. If you'd previously used equation 1 in step 6, you're going to use equation 2 to check your answers. If you had used equation 2 in step 6, you'll be using equation 1 to check your answers. This may be a difficult topic to begin with, but if you do it correctly and you follow these steps, you're going to be really proud of the final product when you see what you managed to accomplish. Let's go into the practice now. So here you've got 8 questions, and each question involves 2 equations to be solved simultaneously. Before you start, have a careful look at these equations and remember step 2. Check that both equations have either the same number of x's or the same number of y's. That is, that the coefficients are the same. Can we solve all of these questions? Look carefully, because you might find some questions that you won't be able to solve based on what we've covered so far this lesson. So let's just go ahead and cross those out. Take a minute to see if you can spot which ones you cannot do right now. We can't do question 3. We don't have the same coefficients for the x's, 4x and 3x, and we don't have the same coefficient for the y, 3 and -1. We can't do question 5 because we don't have the same number of x's, 2x and 4x. And although you may think you have the same number of y's, this is positive 4y and this is negative 4y. Those won't cancel out if we subtract them. Question 8. Clearly we don't have the same number of x's and we don't have the same number of y's. It doesn't matter that the number we have on the right-hand sides are the same. We can't solve these equations just yet. So go ahead and try to solve questions 1, 2, 4, 6, and 7. Make sure you show all of your working, starting by labeling your equations, and don't forget to check. Go ahead and hit pause and do that now, and hit play when you're ready to take it up. I hope you had a chance to hit pause, because here come your answers. Now, I hope you don't actually need to check because you've already done your own checks, but it's always good to feel reassured that you've done it correctly. So for question 1, first I did my subtraction, and I got this equation. -y minus 2y gives me -3y. I hope you paid close attention to the plus or minus signs for these. If you have a mistake there, hit pause, correct it, and see if you can go through to the right answers. My correct answers for y would be -2, and my correct answer for x would be 8. For question 2, first I do my subtraction, and I end up with this single variable equation. Again, I hope you have the correct positive or negative signs there. If I solve this equation, I'll find that y is equal to 1, and substituting 1 for y into either of my two equations, I'll get 1 for x. Question 3, we said we couldn't do just yet, so on to question 4. When I do my subtraction, I eliminate the y's, and if I solve that single variable equation, x is equal to 6, and substituting into either of those equations, I should find y is equal to 1. Question 5 we can't do just yet, but question 6, by subtraction, I will eliminate the x's, And I've already got the answer for y is equal to -2. Using either of those equations, I should be able to find that x is equal to -3. And the last question we could do, question 7, subtracting those equations, I will eliminate the y's. So 2x is equal to -4. Solving that remaining single variable equation, I'll have x equals -2. And substituting into either of those equations, y is equal to 6. So how did that go for you? Hopefully, since you've done your checks, there were no surprises here. But if you did have difficulties and you couldn't find your mistakes, please let me know down in the comments section and maybe I can help you out there. Otherwise, keep up the good work, keep practicing, following those steps and labeling your equations, and watch out for our next lessons on solving simultaneous equations where maybe we don't have matching coefficients for either of the variables, like the questions 3, 5, and 8 that we skipped over today. So I hope you're looking forward to that lesson as much as I am. If so, maybe you want to give these questions a try on your own. Let me know down in the comment section how you do. See you soon.